In this video, we are going to learn about the vector spaces. Vector spaces is a structured space in which the vectors belong. Vectors, they are the objects that can be added together and multiplied by a scalar so that they remain objects of the same type. So even if the objects they are added together and multiplied by any scalar value, it will result in the same type of objects. Then another one term that we will be learning in this vector space is related to group. So group is a set of elements and an operation that is defined on these elements keeps some structure of a set with no change. So the set of elements we need to identify. Using this group we need to identify whether the set of elements under some operation or defined or some operation that is defined on the set of elements, it results in the some values that belongs to the same set. So even if different operations are performed or the operation is performed, resulting elements will be the same. And it so means it forms a group. So some properties are there in order to say that the set of elements under some operation, it is inside a group. So those properties we are going to learn in this slide. Like here we are considering a set G and an operation that is defined over this symbol. So operation can be either plus or multiplication, scalar multiplication or addition. So any operation, it will be defined like this, that is an element from set G cross an element from the same set will result in the another element that also will be belonging to the same set. So this is the way you will be defining the set G. So the set G, when under the operation that is given, either scalar multiplication or addition, it can be formed or it can be called a group if the following properties it holds: closure property, associativity, neutral element, inverse element. So here first we can see the closure. So for closure property for any set G under the given operation, for all x comma y2 elements will be taken, that is an element of G, and perform the operation that is given inside the perform the operation that is being specified. So these two elements, after performing the operation specified, the result also it need to belong to the same set. If so means it satisfies the closure property. Then associative property is like we are considering three elements from this set and the grouping of those elements by performing the given operation, it should result in the same value. Okay, that is x operation y combined together, and then after the result will be added or multiplied with the third element. That is the same result given when the first element is multiplied or added with the second and third elements combined. Okay, so this is the property of associativity. The neutral element is like there exists an element E. So E here will be considered to be as a neutral element. An element will exist that also will be an element of set G. For all x element G, that is a set, if operation is performed on that element, you will be getting the same element. Okay, that is, if there exists a neutral element inside the set in which the operation, if it is performed on the any element that is found in this set, it results in the same element. Here also the order of execution, it is not, it won't be affecting. Either the neutral element can come first, or the element that is taken from the set can come as the first operand. Anyway, the element that is considered will be obtained in the result part. So for that, you can take the example. If I am taking the multiplication operation, and real numbers if I am taking, means if I am taking 3 as a real number, I need to get the result as 3. That is the same result. So real numbers means the neutral element I can take it as 1. This is one example. Okay, neutral element can be taken as 1, so that after performing the operation, that is into multiplication on that neutral element, it gives the same element, that is 3, in the right hand side also. Okay. If it is a addition case, means same thing over the addition. If it need to be defined, means 3 plus what value you will be getting the result as 0 in case of real numbers. You can take the value as sorry, not 0, the same element. Here you need to get the same element 3. So here you can give the value as 0 in order to get the same number 3. Like that you will be able to define that there exists an neutral element in the set. Then next, fourth case is inverse element, in which for all x element G, there exists y element G, which means y will be the inverse of the x, such that x operation y, that is addition or multiplication on that inverse, you will be getting the neutral element. So here the order, if it is exchanged, then also you will be getting the neutral element. So for example, if I am considering multiplication and taking the element 3 as an x value, then for multiplication the inverse of 3 is like 1 by 3, that is x inverse. 3 inverse means you can take it as 1 by 3. You will be getting the result as 1. So 1, it belongs to the real numbers. So this satisfied. If addition operation is taken, means real numbers over addition, if it taken, means 3 plus some number, that is the inverse will be taken. So in case of addition, the inverse will be like the negative of that number. Okay, negative of that number. So in that case, it will be giving 0. So 0 also, it belongs to the 0. It can also be treated as the neutral element. So these are the 4 cases in which we can say that if given set, it belongs to a group. In addition to these 4 cases, if the set satisfies the commutative property, that is x operation y gives the same result as y operation z for all x and y element of G, which means 3 operation 4. If I take some addition or multiplication, it should result in same result as 4 plus 3. Okay, so real numbers over addition or real numbers over addition, you can say that it comes under the abelian group. Okay. Then there are some more examples like this. First we can see z comma plus. So here some notations are there in order to represent the real numbers, natural numbers, complex numbers, like that. Some notations are there. So here, in order to form a group, you need to enclose the set and the operation within the bracket. So some text will be following like angle brackets and some text will be following the parenthesis. So in our textbook, it will be following the parenthesis. Okay. The group means within the parenthesis, the set is included. Set that we are considering will be include followed with the operation with which the elements on the set will be performed. So here Z indicates the set of integers. Z indicates the set of integers. So first example is like set of integers under the operation plus. Is it an abelian group? That we need to prove. So first, what were the properties? Closure it should satisfy. So Z integers means you will be having negative, positive and 0. Isn't it? Inside the set you will be having the negative values, positive values as well as the 0. You will be having all the whole numbers inside this set. So commutative property, closure property is like when you perform any two elements addition, then it will be resulting in an element that also belongs to the set. So if I am taking any 1 and 3, two numbers if I take means that is an element of Z. After performing the addition, you will be getting what the result? 2, which belongs to the set, that is Z. Okay, so first property will be satisfied. Second property, what was the property? Associativity property. That also you know, combining the integers into group and performing the addition operation, it will be resulting the same result. Then third property is like neutral element. There exists a neutral element which gives the same element as the output after performing the addition operation. So if I am considering 3 plus some neutral element is equal to 3, it should result in the same element 3. So neutral element can be considered as 0. So 0 is an element of this set, so that third property also is satisfied. And then next you see case with the inverse. So for inverse, we will be taking two elements. That is, if I am taking the elements as 3 and minus 3. 3 and minus 3 if I am taking, then what will be the result obtained after performing the addition of 3 and minus 3? You will be getting the result as 0. You will be getting the result as 0, which can be treated as a neutral element. Okay, so the core property is satisfied. Together with the core property, you need to satisfy whether it satisfies the commutative property. So for commutative property is like you need to take two elements 3 and 4 if I am taking means it will gives the result 7, which is equivalent to 4 plus 3. So, commutative property also it satisfies. Hence we can say that Z plus it is an abelian group. Okay. Now next we can see whether the second one n0 comma plus is not a group. So n indicates the set of natural numbers. N0 means that the set of natural numbers, it should include 0. Okay, it should include 0, and we need to perform the operation on addition. That is, addition will be performed in this set of elements, and we need to check whether it forms a group, whether the elements that will be obtained after this operation, it results in the same type. So for that, you will be able to know that first property, closure property. After closure property, you will be any elements from the natural numbers. If you take any elements, you will be getting the result also a natural number after performing the addition operation. Okay. So, but So hence it proves the closure property.